Good morning, ladies and gentlemen. I'm Dave Deptula, AFA's Dean of the Mitchell Institute for Aerospace Studies, and welcome to the next event in our Aerospace Nation series. We're really pleased today to have with us Mr. Preston Dunlap. Mr. Dunlap is a Chief Architect for the Office of the Assistant Secretary of the Air Force for Acquisition, Technology, and Logistics. In this capacity, he oversees technology development to ensure the Air Force acquires the right systems to meet the needs of a complex future. Specifically, and I'm sure what's of interest to all of you out there, he's responsible for the very critical Advanced Battle Management System. Prior to his current position, Mr. Dunlap was a national security analysis missionary executive at the Johns Hopkins Applied Physics Laboratory. He also served in a variety of roles in the Office of the Secretary of Defense, including Director of Program Analysis and Chief of Staff to the Director of CAPE. So welcome, Preston, and thanks very much for joining us today. I'd like to start off by giving you an opportunity to make a few opening remarks on the current status of ABMS, the critical challenges facing your team, and some of your top priorities as you look to the future. So over to you.
General Deptula and team, thanks for having me on today. It's a privilege to be here with you and all the august folks that we have joining us on the screen today in this virtual environment. So thank you for setting this up, and I look forward to the opportunity. It's a real great time to be part of the Air and the Space Force. A lot of exciting movements happening, led by our Secretary and General Raymond, our Chief of Space Operations, and General Goldfein, our Chief of Staff of the Air Force. I thought we'd actually start by thinking back a little bit. So if I could ask Camilla to open the first slide while I'm talking here. Let's take ourselves back a bit. Go to the next slide, please. To World War II. So let's think 1940s. And you've got an aircraft and a bunch of aircraft that are fighting in the European theater. You've got an intense World War II fight happening. You've got aircraft like the P-47s pictured here on the screen. Let's go to Corsica and Italy area. Aircraft are landing, highly damaged. One aircraft is on fire as it lands back at the airfield, hits another aircraft on the ground, wing comes off. Fighters are needed, bombers are needed to go back into the fight, and there's no time. You've got an engineer, corporal, and a small team that are looking at this situation, recognizing that they've never seen this before. They've got to get this aircraft back into the fight, don't know how. And so they look at the field and see, well, we can pull a wing off of another aircraft that's been even worse damage, and then put it on this aircraft and see if it works. Well, they didn't know. Would it work? How will it work? How long will it take? Will we be putting the pilot in danger if they were to get back into this aircraft? So they just did it. They saw the scenario, they saw what needed to happen, and they used their innovation and ingenuity to move fast and get the job done. That said, they were really nervous about putting the pilot back in the plane. Pilot took off, nervous, and then ended up coming back, flying upside down inverted, back over the base. Wing worked. First time it had ever been done, putting an entire new wing in the field on the aircraft. It was an amazing sort of feat, and one that captures the spirit of moving fast, being creative, and trying stuff very quickly and early in a very difficult scenario. How do I know about this story, and how do I know that this happened? Well, the guy sitting on top of that aircraft is my grandfather, Dennis Dunlap, who's 99 this year, and was one of those lead engineers that actually made that happen. I bring that up because what you're seeing now with the Space Force and the Air Force is recovering of that same passionate energy to be able to do things faster, differently, smarter, and more creatively. And now, unlike in World War II, we're actually empowered by digital engineering, interfaces, and standards to be able to provide a surety and testing and experimenting early to be able to know how things will play out without having to just put that pilot in the cockpit and hope for the best. And that's really is a sort of a story, I think, that we're seeing just take place across the Space Force and the Air Force. And it's a really exciting time to do that. I know you guys are particularly interested in the application of those principles to all-domain command and control and the Advanced Battle Management System, which is the Department of the Air Force, the Air and the Space Force's contribution to making all-domain command and control real. So if you could advance one, please. The way that the team is approaching this, and it's a phenomenal team, is basically taking cues not from just our own sources, but actually looking at the way the commercial world has moved quickly and adopted over the last 20 years in the digital age. The first, you'll note there, if you're watching along on the screen, that our goal here is to be able to partner closely with the other services so that at the end of the day, we can operate as one Air and Space Force, one joint force, one coalition and partner team. No single solutions, but being all of those many capabilities operating as one. And that's the goal. And that's an imperative by our operational warfighters who see under the National Defense Strategy, no single platform, no single service being able to solve all problems, but a need that we need now to be able to integrate that joint team together. And all the services are lockstep in achieving that objective. And so you'll see when we talk about those capabilities as an Air and Space Force, we'll often use that moniker one on there to remind ourselves that we want to be part of the one DoD team and the one intelligence community team. If you could advance one, please. The path that the team is taking is not unlike the commercial innovation space, one of which I came from years ago in the dot-com era and the startup world before coming to the government and then to Applied Physics Lab. The first step that we want to take to be able to make things like the connectivity lightning bolts that we see in all of our slides and pictures actually real, and the talking points about artificial intelligence and machine learning that we struggle to actually make real. Well, why is that? The secretary and our two chiefs have made it a point in the budget to resource all of the steps that are necessary to actually make those talking points and that dream a reality. The first thing is getting good at software. You've heard a lot over the last 2 years about DevOps, development operations together in the software world. That's a critical first step to be able to move at the speed of relevance and the speed of software. Next, please. Step two, like the journey that the commercial world took when cloud took off about 15 years ago or so, all of a sudden now software is able to operate at great scale and capacity so you can get more processing and more efficiently. In our case, we care about that across a bunch of classification levels. And next, please. Then when the smartphone world came, we moved from flip phone to smartphone. Now we have devices that touch and provide information to that cloud and then pull information from that cloud to be able to expand not only the capacity, but also the information. And next, please. Then really a bit of a discovery. It wasn't a pre-planned activity on the part of the commercial companies, but the realization that now all of a sudden with that processing capacity, the data is available and can be used in a way that unlocks it that didn't happen before. And so then finally, the next click, please. Then all of a sudden those algorithm builders in the in the 80s and 90s with machine learning and neural networks that were really relegated to the academic journals and the realm of theory could all of a sudden apply on top of the data that existed now in the cloud, those algorithms to all of a sudden birth the great gains that we've seen out of Google and Uber and Amazon and others that have harnessed and employed artificial intelligence and machine learning. And our issue as a government is we haven't taken all the way through those steps. And so what you're seeing the Air and the Space Force do is take advantage of the current that has moved very rapidly in the commercial world and then adopting it and applying it in the military context and applying military specific needs associated with it, but ensuring that we actually do all of these to make those talking points of lightning bolts and artificial intelligence actually real. That's the path and sort of the framework. I know many of you are also interested in the architecture and how it fits together. So next, please. What we've found is a good way to describe this as a battle network or an internet of military things. Next click, please. What we have in DoD is a recognition that we have planes and ships and satellites and ground stations and even data, but they tend to be nodes in and of themselves or islands in and of themselves. And so one more click, please. On the left and right, you see we've got sensors and we've got effects. And in some cases, if the sensor doesn't affect, or maybe it's a one-to-one relationship, and we're happy when we actually get one sensor to be able to pass information to another shooter to take an effect or some kind of effect that we need. But it's not a many-to-many relationship. And so what we want to do is make these things pulled into the internet. So next, please. At the bottom, you see a need to be able to build that connectivity pipeline across a range of pathways to provide a surety and transport. We want to flip the way we typically think about things in the military, where we assume that we have perfect bandwidth, perfect connectivity, and then struggle when we don't. The commercial world does it the exact opposite. How do we struggle in a limited connectivity environment or low bandwidth, and the ability to move across different networks and connectivity? And that's the principle that the Air and Space Force are adopting here. But it's not just connecting any sensor and any shooter or any system together. Next, please. We also have to then be able to process the information that rides along those pathways in a secure and an efficient manner to be able to achieve the objectives that we need. And so that secure processing element is a real core piece of this, where the data then gets unlocked. And in the global cloud, where we have it with a bunch of phenomenal commercial cloud vendors that work closely with the government. But then we also need that edge cloud right with you, whether you're on a tank or a submarine or a desert tent, or inside of one of our handful of operation centers in a brick and mortar building. We need to be able to operate in all these ways, and we can do it seamlessly in a disaggregated fashion, so that when you're up on the edge, you can pull information back and forth from that global cloud, and when you're not, you can continue operations down at the edge. And we can do this with the adoption of commercial technologies that enables us to move at the speed of that commercial relevance. Next, please. What's inside of that cloud, and the big cloud and the local cloud? That's where we move data, applications, and artificial intelligence, not just in the big space, but also out on the edge there, to be able to operate where you need it and when you need it. And finally, one more click. Inside of each of those categories, there's a roughly 20 or 30, different individual product lines, or we'll call them Lego blocks, that need to get snapped into place to be able to make this new architecture and approach real. It's not new for the world. We all experience it when if you're in the government, you get out of the Pentagon or your base and you go use it at home. Same construct, same approach. How does it all work together? Well, underpinning all this is digital engineering, open architecture and standards that allows those Lego blocks, just like real Legos, to actually snap together and work to great effect. Whether that's translating across different systems or direct connections or employing commercial processes. So that what you can do from a military perspective now is allow the warfighter and the operator to be able to get the information he or she needs on the edge, whether that's a soldier or an airman or a space professional, and you can do that regardless of where you are. Instead of having to pick the individual to do the mission because they happen to be in the right place, in front of the right computer, in front of the right time, and giving the power of all this information to the people that need it. And that's the goal that we have here as part of the Advanced Battle Management System and all domain command control. You can close the presentation. Thank you. Where are we at in this process? You asked about, challenges and where are we going? One of the fundamental approaches that we have here is normally we would take a set of programs, 30, here, and we would run them through a 7 to 10 year process. Put a bunch of material together, fix requirements and draw a line, and then hope 7 to 10 years in the future we get the thing that we needed. Problem is, as you all know, for upgrading all the software that you have and the devices that you have, is that the internet moves at a rapid pace, and we, as a government, are no longer in the driver's seat in many of those technologies. And so we need to be able to rapidly pull those on. And so the team has come up with a phenomenally creative idea, and it's one that has been used by the special operations community for years. It's getting operators and developers together to then push technology in an experimental approach and deploy it with the warfighter fast. In software, back to that growth plan, if you will, DevOps together for software, getting rapid releases of information out in the software and the digital world. Now the Air Force and the Space Force are taking that and applying those principles to software and hardware, where it's based on others being the primary driver of the technology adoption. And so what you're seeing is a commitment to every 4 months pulling systems together and integrating them, and then building out this architecture piece by piece by piece, and growing and adopting and learning and changing, where we move from normally having to have faith and hope that 7 to 10 years something comes down the pipe that is what we needed, but it's probably too late and out of date, to faith becoming sight every 4 months, as the capability grows and adopts, and you can learn and change and adjust as we move forward. So a very exciting opportunity to be here, the leadership of the department, the push of Congress to be able to not only provide the authorities to do this type of rapid, fast-moving, get capabilities delivered to the warfighter fast, is exactly what Congress has asked the department to do, provided the authorities to do so. And so it's just exciting to be able to see warfighters every 4 months actually say, I want to go take that at the 4-star combatant commander level and go back and actually use it at their command. Happy to talk more about those specifics in any of the upcoming exercises and demonstrations as we go forward. But Dave, I hope that paints a little bit of a landscape for you and the team here about the approach that the team is taking, how the work is going, and the speed and pace by which the department is moving. It's really exciting.
Well, thanks for that insight, Preston. That's just an absolutely fascinating story about your grandfather, and it certainly makes it real and pulls the past into the present and looking at the future in where you're going. It's great to see that people are coming to realize that the next big thing is going to be based on the ubiquitous and seamless sharing of information and getting that information to warfighters at the speed of relevance, as you say, so that they can outdecide our adversaries.
Mm-hmm.
Now, in that regard, one of our top researchers here at the Mitchell Institute is Heather Penny. Heather was the principal on a recent project that we worked for the Defense Advanced Research Project Agency called Mosaic Warfare. Since this topic is right up her alley, what I'd like to do is hand the program over to her to dig deeper into the subject with you. So Heather, over to you.
Thank you, sir. And Preston, again, thank you for making the time today. Like General Deptula, I love the story about your grandfather in World War II. You know, as you're aware, the Dowding system in England, which was their battle management command and control system, is what allowed the Royal Air Force to defeat the Luftwaffe when the Royal Air Force was outnumbered 5-1. So we know that we can leverage the power of information, these networks and command and control to enable us not just to have the speed of relevance, but to make our operations more effective. And so it's really, I appreciate your discussion about how you're taking the technologies and being able to build that together to support an operational concept and ultimately a doctrine that will allow us to be effective, efficient, and ultimately prevail in any kind of operational scenario for the future. So, but it seems like the vision that we've had for the Air Force has evolved over time. We've heard multi-domain command and control. Now we've got advanced battle management systems, and now joint all-domain command and control. So would you mind taking a moment just so that we can baseline our understanding to describe this evolution and what the difference is between ABMS and JADC2?
Yeah, great, Heather. Thanks. I appreciate the historical analogy. It's important to remember and learn from what has happened in the past. Yeah, so here's the operational objective here, though there are many. So technically it's creating that connected Internet of Things in the military. Operationally, we've tended to be stuck in more of a deconfliction in terms of all domain operations over time, rather than an integration of operations. And so the operational imperative that all of the Joint Chiefs and the combatant commanders have recognized is that to be able to fight and win in the contested environment in the national defense strategy requires all elements of the force, sensors and decision makers and weapon systems to be able to not just know how to disassociate each other in sort of time and space, but also to be able to work together, and that's an imperative. The multi-domain command and control, joint all-domain command and control both intended and effectively the same thing. The intention is to be able to represent from a concept of operations perspective, getting all domains together, not just one or two domains, but clarifying that it's actually all domains that have to work together. And we see that now. It's no surprise. Something that happens in space immediately affects something that's happening on the ground or in the air, and vice versa. And so the recognition is that it's not a new thing, but now because of the speed of those interactions and the immediacy of those effects, things like the phone call to phone call to phone call, chat room type operations aren't going to cut it in the age of modern warfare. And so we've got to be able to do like those before us did, to be able to adapt and move quickly. And we are fortunate to actually have a thriving commercial base that has been pushing this technology forward, both alongside and sometimes surpassing us in these capabilities to be able to do that. So joint all-domain command and control is that joint approach that's led by the chairman of the Joint Chiefs to be able to achieve that operational concept. In this year, the Department of the Air Force was asked to take on the integration role with all the services to write the doctrine and the concepts of operation for global command and control. And we're doing that hand in glove with each of the services. There are other tasks associated with that other services have particular leadership roles in. Each of the services then is developing capabilities to fit into that joint staff-led and Chief Information Officer, CIO of the Pentagon, Dana Deasy's team as well. The Air Force and Space Force contribution to the technology, that's what we call advanced battle management, family of systems. So if you're talking technology, JADC2 and ABMS from an Air and Space Force is the same thing. But JADC2 is that operational construct, the approach to warfare that is upon us. And so then all of the services are driving to build technologies for each of our services that then fit and nest within that and also enable that as quickly as possible. So advanced battle management isn't a single platform, right? It's we just talked about the architecture. It's a set of capabilities and pulling current and future systems together to be able to actually achieve the end state for the Air and Space Force to support the chairman and the combatant commanders.
Thank you. So you mentioned obviously that the joint all-domain command and control is more of the doctrinal type of approach across all the different services, and the Air Force is the lead for that. But Defense Media has reported that despite the thought leadership of the Air Force and the investments that we're making, that the Navy and the Army aren't really on board. So they're not making the resource investments that are aligned with JADC2. Can you provide some more insight regarding the investments and the resources that you're seeing the other services make and how they're responding to the Air Force's leadership regarding this all-domain command and control doctrine?
Yeah, it's it's been really exciting to see the chairman and the Joint Chiefs really take ownership and point on all things related to command and control in the joint world. That's allowing all the services, to include our two services, be able to operate and support that joint vision that they have. And so you're seeing all the services be able to build and program against those needs and help the joint staff and the Chief Information Officer be able to help where there's standards that need to be in place to be able to ensure interoperability across our systems, that they've taken on the role of being able to orchestrate that, as well as through the Research and Engineering Office in the Secretary of Defense's Office for fully networked command and control. So I'm seeing a lot of positive gains there by their leadership, all of us sort of falling in and supporting that joint vision with each of our own programs. The Navy has their own set and working on the tactical grid work as part of their aspect. They've been working on air and ship integration. The Army's got IBCS and tactical networks that they're also building. Air Force and Space Force have ABMS. So what all the service chiefs have agreed that doing capabilities and building them as quickly as possible to support the all-domain command and control vision and need is at the top of the modernization list for all the services. And the chairman and the Secretary of Defense have both made that very clear, both in the previous budget cycle as well as now, that he wants to see all of us investing, and not only investing, but actually delivering capability in each of those areas. And so we have an opportunity under the Joint Staff's leadership to be able to get together, not only for the concept development piece, but also partner with each other like the JADC2 and ABMS demonstrations, or Onramps as we call them, every 4 months. So we're orchestrating them, but those are joint activities that we're working. Similarly, we're trying to plug into other service activities and operations as well, so that we can ensure that the capabilities are being built in a way that works for all of us as opposed to just one of us. Again, the point is that we're able to operate as one team and integrate that force at the end. So call me an optimist on this one. I actually think that I'm seeing really positive progress. Very thankful for the chairman's and the vice chairman's leadership, both on bringing the services together here, as well as in particular the vice chairman's thrust to renovate the requirements process that allows all of us to be able to not stick with something and then continue down that road for a decade knowing that it's the wrong thing, but to be able to adapt and move both as adversaries move as well as technology moves. Adversaries they're doing it. So let's not hamper ourselves. And I'm just very proud of what the department's leadership is doing in that area.
No, you're absolutely right. I mean, if we freeze requirements now, especially within this type of project, we'll basically relegate ourselves to obsolescence because the pace of technology is so much faster. I really appreciate the fact that you mentioned that the demonstrations that you're doing, the on-ramps you're doing are bringing together the different services, because we know that we'll need to have the ability to share information across all the domains to be effective. And that's what you demonstrated in December, where you were able to construct a kill chain that spanned many different domains. But that kill chain is just one element, one small element of the information pathway that we need. And it doesn't necessarily include all of the decision nodes and the effector nodes and the broader elements of battle management. So we know that unfortunately due to COVID, we've had to delay the second demonstration of ABMS. So I was wondering if you would take a few minutes and talk about what your plans are for that second demonstration in August, how the development of technology in this interim may or may not change what you'll do and demonstrate within that demonstration, what you're hoping to learn.
Yeah, great. So yeah, December was very exciting. The services came together under the Deputy Secretary of Defense's leadership and DoD CIO's leadership, and in partnership with the U.S. Northern Command, General Shaughnessy, commander, setting the operational context. The many things happened there with several sensors and decision nodes. The goal was to be able to push and see how far the department could get, the DoD department could get in 4 months. And it was very impressive, both what we learned about things that didn't quite work and then the things that we could actually pull together. The four things that the team was able to successfully achieve that I might highlight, one is enabling two aircraft that can't talk to each other in a relevant, highly contested environment way to actually talk to each other. And by that I mean shared limited data, and then continue to grow since then. That's been a continual problem and an issue. And much like the World War II example with my grandfather, the challenge that we presented ourselves was, let's just do it and figure it out and not wait. And the team did it, and it was amazing. More to be done, but it's a great start. A second thing is recognizing that we need to be able to integrate not only government, but commercial capabilities in. And so the team was able to integrate a low Earth orbiting proliferated LEO satellite constellation, in this case Starlink, to be able to pull into a military platform the use of an alternative communications pathway with good bandwidth there. So we did that in December. Also, to support this, we need to move out of that construct of a single brick and mortar facility with localized software and applications to support those decision makers, and provide, kind of like we're talking today, in a more virtual environment to be able to operate where you need it, when you need it. And so we demonstrated for the first time a cloud-based command and control system. And then number four, the ability to move a seamless common operating picture from that brick and mortar facility out to a rugged tent area. So sort of four key, principles to be able to move. And there were Army radars, Army shooters, Navy ship out on the coast, Coast Guard participating, Special Operations Command, and so on. So it was a great scenario pulled together by our Northern Command partners. Though we've had to delay due to COVID the April on-ramp exercise, as sort of history here played out before us would have it, the team immediately responded to the COVID situation. So if you think about all domain command and control in ABMS is delivering that seamless ability to operate in a disaggregated posture wherever you need it and provide the information and receive the information when you need it. Frankly, it's not that different from what we're having to experience now under COVID. So with stay at home, move, social distancing, and then we have operators out on the edge like New York City with Northern Command actually operating with healthcare workers to support them. And so to that end, though the team was anticipating demonstrating early prototypes of some of the ABMS capabilities, instead of waiting for the summer timeframe or late summer to do it, we've actually pushed forward and have begun to deploy some of the capabilities to support the COVID fight. One of those is a device one, which is the ability to process classified information on a device that's unclassified when you're not using it. So you could literally throw it on the street, no problem. Wouldn't recommend it, but no problem. But when you use it, you actually can operate and access the information you need much like you would in your office. So it's important for the warfighter. We're going to demonstrate that here in April, but now it's actually supporting the ability for people to not be crammed in small spaces doing some of the classified work. And we're deploying 1,000 of those in about 3-week sort of cycles now to get them out to the force to be able to operate. So that's helping folks now. Also on the Northern Command side, the team that has been working the ABMS demonstrations also pulled together all of the technology that we have, and we deployed an unclassified tablet device in this case, and provided it to all of the healthcare workers in the Javits Center, as well as out on the hospital ship that were associated with Northern Command. And then we've been pushing data and applications so that you can get real-time awareness of where people are, their health status, and then build in artificial intelligence algorithms to begin to get ahead of the curve as much as we can on where COVID might be going. And so from both a classified and an unclassified world, seamless devices, mobility, data, and applications where you need it, when you need it, are actually being demonstrated before our eyes in a real world current operation. So in some sense, you could call that we're actually doing a current ops on-ramp to be able to support people and keep people safe. But you asked about the upcoming more military-focused on-ramps as well. So we have a target aim where we're looking to execute an expanded version of what was going to happen in April in the late August, early September timeframe. There's going to be a variety of sort of key adjustments there. One is that before in December, it was mostly a Northern Command focused. We now have a Space Command and a Space Force. And so the predominant thing here is we're going to have the U.S. Space Command Commander, General Raymond, actually be the support head commander for the first time, as opposed to a supporting commander. So that's going to be very exciting to look through and work how he can operate and be able to do what he needs to do and his team needs to do to operate and be effective. And so we're actually going to start the on-ramp there with supporting him. And then we'll have more Northern Command support, like we did before, with keeping custody of a bunch of different cruise missiles and things on the water, things in the air that are coming through, and being able to capture and track that type of activity. And then we've actually begun a partnership as well with Admiral Richard and his team on strategic command as well, to have an element where we can continue and support sort of the full range of operations as well. So very excited about that increased scope. Though we had Lego blocks demonstrated in December, the other aspect that the team has built here for us is to be able to actually integrate more of the full kill chain or the full kill web. So we've got a lot more sensors, and we actually have live fires that will be happening in each of the domains associated with the activity, so that we can be sure that when the system and the digital stuff thinks that it's working, we can actually see whether it's really working, and providing that information to track or provide target quality information. And so that sort of complete kill chain is important. It's also important for us because you can always build the technology and hope that it comes later and can be integrated at some point. So the team's also just driving out all that integration risk by pulling those platforms in early to be able to put the capabilities. And then with the power of software being able to expand over time, you can deploy it, leave it behind with them, pull data off the system to learn and make it better, and then just redo it with even more advanced capabilities going forward. So very excited to see that happen in the upcoming exercise. And I'll just also just sort of give you a little bit of an exciting thing to come, more to follow at another date. But we've also struck a partnership with Admiral Davidson, the Indo-PACOM commander, as well as continuing with General Raymond for the subsequent on-ramp to happen after that. So very excited about taking that out in theater to the operational edge as well.
Yeah, especially Indo-PACOM. I mean, that is such an important theater for us to consider because it's one of our hardest problem sets. And the experimental approach, the demonstration approach, where you're doing iterations and learning and having successes, and then taking some of those elements that might not quite have worked the way you intended them, is a crucial piece of ultimately building a successful joint all-domain command and control and the technology, the ABMS, that supports that. Going back to the historical example, the doubting system, that battle management system that in command and control that allowed the RAF to save Britain from the Nazis, it took them over 5 years of experiments to be able to refine that system. So again, kudos to your overall approach of demonstrations and experiments. It's clear that there's this interactive relationship between the technology and the operational concepts. In some cases, new technologies like networks and artificial intelligence can enable the development of new operational concepts. And sometimes it's the changing strategic context that demands new ConOps, which in turn then drives the requirement for new technologies. So where do you think we are in this dynamic, and how is that impacting your experimentation plan?
Yeah, great. So it's in this case, to be able to move fast, you've got to have both together, and both have to grow and learn from each other. That's why rather than simply stick with we call these on-ramps, you could have called it a demonstration or experiment or a test event. The truth is it's all combined together. That's the only way you can do this, given the pace of technology and frankly, the pace of potential adversaries and how they're adopting it. We have to be nimble and flexible. This is really taking a page out of both commercial playbook as well as the special operations community playbook. SOCOM calls these, development and operations together, capabilities, op evals, they call them. And so what we've got here is the concept writers and the doctrine writers and the technologists and the at the edge warfighters all sitting together or separated in sort of the virtual world, but working together to be able to achieve the operations. That's why we decided to go with actual combatant commanders, both the 4-star at the head who'd be running operations, but also their team using and exploring the technology, because what we want to be able to do is, both show them what can be done and what's available. In some sense, they all know it because they have a lot of this similar, we'll call it, though a different context, at home. But we tend to sort of remove that thinking when we go to the office here, and we think, well, we just can't have that kind of connectivity, can't have that access to data, and so we derive the concepts and the doctrine knowing what we can't do. And so what we're able to do in this process is basically show the world that we need an iPod before there was an iPod. Show the world what you can do. We actually have the benefit of being able to show corollary examples in the world. And then what we need to do is show that it works securely and effectively in an operational environment that the military cares about and that we need our operators to be able to have. And so there's a real important symbiotic relationship there, which is why we have the combatant commanders at the head. It's also, frankly, why we tend to not announce or select which combatant commander or collection of combatant commanders are going to be too far in the future. Normally we'd set a year or 2 or 3 long schedule for a nice drumbeat, and we could do that. The issue, though, is that what we don't want to do is create fixed kill chains where we can bubble gum and duct tape things together. What we want to do is actually represent and reflect what might really happen in conflict, which is uncertainty. You don't exactly know what the combatant commander is going to need me to do from an operator or a technology perspective. And so we're attempting in some way to be able to reflect that uncertainty so that the developers and the product managers have to ensure that they are actually designing in the ability to be agile and flexible within that 4-month period, but then within subsequent 4 months periods in the future. And so this is an exciting partnership with the Joint Staff, with the warfighting side of with the Air Force and the Space Force, who are taking the lead on doing the doctrine work. The Joint Staff has made it clear that they want to use this experimentation campaign with all the services to be able to refine and improve that doctrine. I think what we all agree is that you can't wait for doctrine and ConOps to write to start the building. You actually need to be doing it together in that DevOps fashion, but not just for software, not just for hardware, but also in the concept development phase. So I'm excited by what we're seeing. But what you are looking at is in some senses several cultural changes on each of those fronts happening sort of before us. It's needed, it's necessary. All of the 4-star leadership in the services and the department are 100% behind what DoD is doing here. Certainly the Air and Space Force leadership is, and that just sort of, that goes all the way down the chain. And I got to tell you that watching the operators, out in the field, and General Shaughnessy back in December saying, "Look, what the team here did is better than some of my capabilities in the operations centers today. I want to use it now." And now the team is deploying that leave behind capability for him and his team. With the COVID examples, those are the kind of success stories that make the difficult culture and speed challenges and technology enhancements just all worth it, because you're actually getting something out of the system, which makes it both exciting and just really, really just the right move.
You're right. I mean, we don't necessarily have the time right now to wait for a 100% perfect system. We simply need to have something that's better than what we've got right now. And that iterative approach that you're taking is fantastic. The novel elements of that are very different, as you mentioned, from our standard bureaucratic processes. And I'm glad that you mentioned the feedback loop that your demonstrations and Onramps are having with the doctrinal side of the entire military approach. One piece, though, that seems to be having some difficulty catching up is the DoD's platform-centric acquisition model, right? The current programming and budgeting system is primarily platform-centered. And this makes programs like ABMS challenging to advocate for on the Hill, both because the money is so distributed and because the product itself is less tangible relative to these high-profile weapon systems. So how would you recommend going about making the case for ABMS to a skeptical audience?
Yeah, so there's certainly the operational imperative that we have to be able to work together. When you look at operational scenarios that we might be called upon with large geographic areas, large defenses that are trying to keep you out of space, air, ground, sea, it becomes pretty obvious that no single platform, however awesome, will actually be able to get the job done. And what we actually need is the ability to be able to have those many-to-many relationships across the joint and intelligence community sort of team to be able to achieve the objectives. If we follow the sort of the standard approach, essentially you've got a good idea or an operational need, and you essentially have to wait 2 years before you can actually start something. That's the normal sort of program budget process. I'm well aware of it from my time in OSD and CAPE, and there's goodness there. But there's also goodness in being able to be flexible and respond. And so that's why I'm really encouraged by the congressional leadership that has enabled each of the services, and for us, the Advanced Battle Management System, to be able to be that overlay across the capabilities and platforms. If you relegate this to a program element inside of a platform, you will always end up having that connectivity line be the first thing to go in the system. Normally program managers are trained, don't ever make your project dependent on somebody else. And so you gotta control that. And we've seen this time and time again. This stuff just gets washed away. You build one part, but the connectivity never happens. And so you've got to be able to do it this way. So that when those platforms that are the warfighting capabilities, a sensor or decision node or a weapon system of some kind, that what they see is if to use it a verb like ABMS or one, that all of a sudden the power of that platform is all of a sudden exponentially increased. Think if you're in a fighter, I might have my own sensors or maybe the fighters around it, but now if I bring all of the information that the broader DoD and the intelligence community can have to bear on that pilot's decision-making, that's phenomenal. What if you made all the things like tankers, the ability to not only be able to supply gas, but also to be able to make battle management and situational awareness choices to support folks on the fight? If they had the right communications and this mobile ability to do secure processing. These are opening up new concepts of operation and unlocking the power of the platform focused in a way that they never could if all you had was the platform themselves. So it's
Absolutely.
a real imperative that Congress continues to support it, that the Department of Defense continues to build capabilities that are useful and real and meaningful and provide those capabilities. And the good thing is, though we're doing it for the purpose of developing technology and deploying it fast, you actually can see the connections of those platforms and the on-ramp activities happen. So in August, September, you'll be able to see those platforms all of a sudden be up-leveled and have new capabilities that they didn't have before. Those decision makers out there with districts and platforms, they may not be able to, quote, see the network, ought to be able to see the platforms in their areas and their bases, be able to take on the power that they never had before.
And become more relevant. Thank you again, Preston, for taking the time to share your insights with us today. On behalf of Mitchell Institute for Aerospace Studies and all of the Air Force Association, we wish you the very best in this area of ever-increasing challenges. As a reminder to our listeners, the next event in our series will be with Lieutenant General D.T. Thompson on May 12th. We're now going to open the session to questions from the audience who've been listening to our conversation.
Hi, this is Dave Anhalt. First of all, I'd like to thank both of you for what I believe to be the finest Mitchell Hour we have experienced in a long time. And that's saying something because we've had a heck of a good lineup of speakers this year. The vision is so clear the way that you've expressed it. I'd like to take you into a particular domain and have you comment on why it would be so hard for this brilliant strategy and vision to change the way we do nuclear command and control. I've heard it said that nuclear command and control has to be separate from all domain command and control. It's its own thing. It's a very finite thing. Send options to the President of the United States, have the President of the United States send a single option out of all of the things that we could do to exercise our nuclear deterrent. And that has to be done in a fashion that it would be dangerous to have it be just another element in all domain command and control. What are you doing to try to influence that? Or is that one of your secret plans for phase 3 of this thing, is to go down and help General Ray exercise his responsibilities on NC3?
Well, I believe many of you probably heard General Ray recently say that if he had another dollar, he would put it towards getting data. And sort of General Raymond and General Goldfein have both penned an op-ed together where they view data as a principal currency of modern warfare. And so I think you're seeing that through the thought processes of Admiral Richard and General Ray and all the not only thought leaders but fine military operators that actually make it happen in the worst of times. Yeah, I'm very excited by the vision that those leaders have for nuclear command and control. In some sense, it's a specific application of the Joint All-Domain Command and Control world, and it's important that JADC2 and for us at ABMS be able to provide opportunities to be able to move information when it needs to get to where it needs to be. So we're fully thinking about that. There really isn't a domain that we ought to not be thinking about in this regime. And so we are looking at both the ability to do mobile command and control as part of that secure device concept that we talked about, and also be able to provide a bunch of opportunities or options to be able to provide multiple pathways for command and control in conflict. And so we'll always have the ability to have that the separate thin line type capability to support operations as we need it. But we always want to have reliable and assured alternative pathways that we move forward, and we got to do so securely. So glad you asked the question. It's something that we've got to keep in mind and integrate here as we move forward. Architecturally, there's really no difference. Operationally, then there's different security principles and approaches that we'll have to work out. But what I've heard, and it's been very clear from both Admiral Richard and General Ray, is that they need to be able to move information however they need to move it. And it's most important, and in fact, perhaps the most critical ability to be able to ensure that those messages are able to get where they need to go, when they need to go there without latency. And so we're taking that full on as an important attribute of the system. Also the ability to operate in less than ideal circumstances as well in terms of those connectivity pathways. So definitely an important attribute of the system and part of the requirement space there as well. Not the only one, but it's certainly an important one.
And the only thing that I would add to that is that the requirement also means that we need to continue to invest in NC3. Because if we don't modernize the whole NC3 backbone architecture, it won't have the ability to be integrated with ABMS and JADC2. So I'd just like to remind the audience that you can raise your hand when you unmute, and then I'll call your name. So thank you, David. Michael Gordon. Okay, Michael, we'll come back to you.
I heard you. I don't have a particular question, but I'm monitoring it, so thank you.
Okay, all right. Steve?
Yeah, hi. Thanks a lot, Mr. Dunlap, for doing this morning. So a few months ago, you provided a great presentation to the press where we saw the quick reference guide with the 6 different categories and the 28 different elements, all ending in 1. And then we heard about device 1, so 29 elements. When I really, I understand what you're talking about with this iterative approach and a different model of acquisition and program management, moving away from the program element, and that how essential that is for a program like this. But at the same time, can you tell us how much that's going to cost for those 29 elements to bring that to the table and to field it at scale, and when that's going to happen? It's a very broad question because I realize there's 29 different moving pieces at least, but it's something we get for all the other defense programs except this one, and I think well, that's the question.
Yeah, cost is an important element. The main approach here, like for the device 1 and the cloud processing, is the ability to actually employ and embrace the commercially available and then commercially portable capabilities in. So that's one of the core principles that we have to be able to manage costs, but also ensure that the system these systems are able to upgrade over time. So for example, for device 1, all of the work that the team did was software based and software security based. And the hardware piece of that are procuring and competing across the vendors that could provide the laptops, the tablets, the servers in the back end and so forth. So we're able to take advantage of the commercial pressures and marketplace to keep the cost down. That's different. Normally it's flipped, right? If we're the primary customer here, we've got to be very concerned about cost growth associated with that. Right now, in some sense, we're the small buyer. The commercial world needs those for general public, private companies. And so what we're doing is being able to then compete those needs and be able to pull them in quickly, which is why we're able to do it so rapidly. And then the issues that then upgrade, we can then upgrade those systems over time just as the commercial world upgrades them. We can't do that normally because we've procured a defense-specific sort of hardware system that prevents us from, we have to go back and then rebuild something specifically. What we're trying to get at is basically just totally go away from that model and allow everything that's possible to move with the wave of commercial technology and allow that to be able to be injected into the system. And so that's modularization. That's the Lego block approach that's important here. And so that we learn and we'll see our actual costs as we do this every 4 months because we're using the real technology. And the teams put together sort of the business and the costs of what each of those 30 product lines think that they're going to need to be able to do over the next handful of years. What we don't want to do then is then be beholden to that, because we want to be able to grab whatever the commercial world is pushing in terms of the latest software, the latest processors, the latest space to be able to move from global cloud to local cloud. And we want to put those apertures in systems or in gateways, and then allow us and the commercial world to mature the software-defined radio and the software-defined network and the approaches behind there. So there's costs behind all those systems. The great thing about this is, and really the approach that you have to take to be able to do this is to leverage and take advantage of the huge power that's out there because of the need for many of these systems to make the internet work, to make the Internet of Things work, to make cell technology work, to make 5G work. And so the mindset that I asked you to think about this is, how can we leverage the power of that huge competitive world that's out there and harness that for our benefit? And that's the imperative that we're under and have the opportunity to be able to take advantage of. So less worried at the moment about some of those cost issues, because if we're in that cycle, then we're actually probably not doing it right.
Thank you. I'd like to move on now to Teresa.
Hi, Preston. Thanks for doing this today. My question, it's kind of a basket is about device one. And I wonder, first of all, can you tell us the security level to which the data is usable? So is it TSCSI? And are other organizations within DoD using this, or are you proselytizing it to them to use? And can you tell us who are the vendors of the platforms, the actual devices? I know that AFRL developed a lot of the software, but I don't know who the hardware comes from. So that's my question. Thanks.
Okay, thanks, Teresa. Yeah, so so this is just phenomenal. So even in a virtual COVID environment, the team pulled together very rapidly the ability to do something that we were going to demonstrate in April for the first time as a prototype. This is interesting on a variety of fronts from the vendor system. So that the secure view, which is what we've developed inside of our research lab, is the fundamental security architecture by which you can do this unclass at rest, zero trust prototype, and then be able to use it. We have lots of customers that are using this throughout the globe, on premises and in buildings. What we've done then is partnered that with NSA, Commercial Solutions for Classified Office, and the really thoughtful approach that they're taking to security to be able to allow mobility and access in the modern era, and pair those together in partnership with NSA, in partnership with Pacific Air Forces, in partnership with Air Force Material Command, and then we developed a very quick opportunity to then be able to provide this. The limitation actually has been in the supply chain with laptop producers and providers, and so we've competed across the space to get laptops in hand that are available, so we get good price, and it's vendor agnostic in this case. Just another example of how we're able to keep costs down there. So there's a long list of particular vendors that you can use the SecureView software on. We did a very quick 5-day authority to operate security review of the system to be able to move out and then expand it. At the moment, actually SecureView is used around the globe by several of our combatant commanders. It has the ability to be used at any classification level, from unclassified up to SCI and special access abilities. The particular configuration that we've done for this to manage the risk posture in COVID is to do it at just the secret level and unclassified. So it's unclassified at rest and provides access to basically anything that you can get in your office at the secret level. And that's sort of managed by policy and choice right now to be able to do that. That's for the COVID posture. For ABMS and the warfight abroad, as needed, what we will do and will be doing as part of this is enabling those devices and the inherent security associated with the ability to operate at any classification. in the warfight abroad, so that what we don't want to do is be reliant on single points of failure across the globe to be able to achieve our operations. That's part of that operational and concept imperative that we have, and we can't get there fast enough. And so what we want to be able to do is provide, if we have the greatest cloud in the world, but nobody can touch it because you don't have a device that can connect, it's useless. And so that's why the Device One line is so important to us. We've got to be able to leverage commercially available devices. It's just an imperative for cost and schedule and advancing, so we're not stuck having to build our own hardware. And then it's incumbent upon us to be able to provide the security and the software on top of that that enables our operators to be on that island, on that aircraft, in that Humvee, in the tent, and be able to get the information that they need. And so you'll see that trajectory associated with the Device One line of capabilities over time.
Thank you.
Well, goodness, I can't believe we've already come to the end of our time with you, Preston. Thank you so much. And I can see that there's still a number of questions for you. You've been a very popular speaker, and we haven't been able to answer all the questions. So we do hope that you'll come back and join us again. Again, everyone remember that we've got our next event on May 12th with Lieutenant General D.T. Thompson. We hope to see you then, and we'll let you know when Preston can come back. Thank you so much. Have a wonderful Aerospace Day.
Thanks, Heather.